Welcome to this video on Year 1 Pure Chapter 6 Prep Practice. So question 1, we're looking at the equation of a circle in the standard form. So for x plus 4 squared plus y minus 2 squared equals 64, then the center of the circle are the values of x, which make this bracket 0, which is minus 4, the value of y, which makes this bracket 0, which is 2, and then the radius is the square root of the constants left over on the right-hand side, which is the square root of 64, which is 8. So the center of this circle is minus 4, 2, and the radius is 8. And then if we want to do something similar, but with an equation where the brackets have been multiplied out, then essentially we need to try and complete the square on the x's and complete the square on the y's, get it into this form, and then from that read the center and radius of the circle. That's probably better than the alternative of trying to memorize formulas. So here we have x squared minus 6x, which becomes x minus 3 squared, and then we subtract 9 to compensate for the plus 3 squared, and then y squared plus 2y can be replaced by y plus 1 squared, but we have to subtract 1. And then we still have the 1 that was over here. And then if we simplify the constants, we have x minus 3 squared plus y plus 1 squared, and collecting the minus 9, minus 1, plus 1 to be minus 9, and then moving on to the other side, we get this equation here, which has center of circle 3 minus 1, radius square root of 9, which is 3. Moving on to question 3, we want to find the equation of the circle center 2, 5, radius 2, root 3 in that form. So if we first of all write it in completed square form, we know it's going to be x minus 2 squared plus y minus 5 squared, because the center is coordinates 2, 5, equal to the square of 2 root 3, which is 4 times 3, which is 12. And so that's the equation of the circle in the easiest form. Now, if you multiply out the brackets, we get x minus 2 all squared is x squared minus 4x plus 4. Y minus 5 squared is y squared minus 10y plus 25. And then if we collect the squares and the x's and the y's and the constants, we end up with the equation of the circle in the form required. Question 4, find whether the point minus 1 minus 3 lies on the circle with the equation x minus 1 squared plus y plus 2 squared equals 5. Well, if we substitute the values of the coordinates x and y being minus 1 and minus 3 into the equation, we find that putting in x is minus 1 and y being minus 3, we get minus 1 minus 1, which is minus 2, squared is 4. Minus 3 plus 2 is minus 1, squared is 1. And 4 plus 1 is indeed 5. So it does satisfy the equation, and the point does lie in the circle. Had we had a number here, which was smaller than 5, then it would mean that the point would be a distance less than 5 from the center of the circle, so it would have been inside the circle. So a number like 3, working at the right-hand side, would mean that point would be inside the circle, and a value bigger than 5 would mean the point is outside the circle. But in this case, the point lies exactly on the circle itself because it satisfies the equation of the circle. Question 5, the equation of a circle center minus 2, 3 to the point with coordinates 1, 7 is in that form. We want to find it. Because the center is minus 2, 3, the equation will be x plus 2 squared plus y minus 3 squared, and that will be equal to the radius squared, and the radius will be just the distance from the center of the circle to a point on the circle. And so if we work out the distance from C to the center of the circle using Pythagoras, we get a difference in the x coordinates is 3 squared, difference in the y coordinates is 4 squared, gives us 9 plus 16, which is 25, square rooted, the radius is 5, and therefore the equation will be x plus 2 squared plus y minus 3 squared equals 5 squared, or 25. Question 6, we want to find in this form the equation of a circle with diameter AB, where we know the coordinates of A and B. Well, if we know the diameter of a circle, then the midpoint of that diameter will be the center. So if we work out the midpoint of minus 2, 5, and 6, 1 by taking the average of the x coordinates, the average of minus 2 and 6 is 2, and the average of 5 and 1 is 3. And so the equation of the circle will be x minus 2 squared plus y minus 3 squared. And then the radius will be the distance between the center of the circle, which is the midpoint of the diameter, and any one of these 2 points. So for example, the distance from minus 2, 5 to 2, 3 is 4 for the x distance and 2 for the y distance. And so by Pythagoras, that distance will be root 20. And so the equation of the circle will be x minus 2 squared plus y minus 3 squared equals 20. And then multiplying that out, we can get into the form required in the question. Question 7. Does the circle with this particular equation intersect the line with this particular equation? If so, find the number of points of intersection. Well, a line will intersect a circle in either no places, one place if it's a tangent, or 2 places if it crosses the circle. That probably reminds us of a quadratic, which can have no solutions, 1 solution, or 2 solutions. And so it's not surprising that if we solve these equations simultaneously, we'll find the points of intersection if they exist. And we can solve them simultaneously by substituting the y equals x minus 1 into the equation of the circle by replacing the y by x minus 1. So we get the equation of the circle becomes x minus 2 squared plus the y replaced by x minus 1 becomes x minus 4 squared, and that's to be equal to 3. And if we expand out the x minus 3 squared and x minus 4 squared out, we get the quadratic 2x squared minus 12x plus 7 equals 0. And now to look at the number of solutions of that, which gives us the number of places where the line and the circle intersect, we examine the discriminant, which is b squared minus 4ac. In this case, the discriminant is 8 because it is the coefficient of x squared, which is 144, minus 4 times the coefficient of x squared, which is 2, times the constant that's left, gives us 8. Because that's positive, it means it has 2 distinct roots, and therefore we know that this line intersects this circle at exactly 2 points. We could work out the x coordinates by solving this quadratic and working out the y coordinate by substituting back into either the circle or more easily into the line, but we're not asked to do that. We just need to know whether it intersects, and if it intersects, at how many points it does. So this is quite an interesting use of the discriminant from the quadratics chapter. Good. I hope that was useful.